All right, guys. Good evening. Okay, so just to get an idea on like the diversity, right? Like, so how many of y'all like have worked with metaprogramming? Like, have you like who of y'all have like previous experience and like let's say like experience with decorators? Doesn't necessarily has to be like TypeScript. Like it can be like Python or any other programming language as well. Maybe just hands up. Just raise your hands up on the Google Meet. Like those are like previous experiences. Can be just basic as well. No one? Okay, no worries. All right, so let me share my screen real quickly. All right, so the agenda for today would be basically we're gonna look into metaprogramming. We're just gonna touch the very surface of it, right? We're gonna look at it in the context of like analysis, transformation, and also memorization. At the end of the session, there'll be a challenge. Of course, as you may already be aware of it, the prize would be basically a 10K voucher. All right, so first things first. Everything that we do is available on this GitHub repo. So let me just real quickly post the URL on the chat as well. All right. Okay. So first things first, what is metaprogramming? Basically, in a nutshell, you can think of a metaprogramming as of a program that writes itself, right? So, but like we basically want to tweak this definition now in the context of AI because then it just gives a different overview or different impression, so to speak. So we would like to say it's basically code that manipulates code. So we would basically give it certain instructions and the program itself would manipulate during the runtime the program itself, taking into consideration of those meta properties. So basically, let's dive into like an example just to make sense of it. All right. So let me open up that repo. All right. Okay. So basically, on this one, this is a basic, very simple TypeScript project. So in this index.ts, I have a class that has two methods. First one, it just computes the factorial recursively. The second one, again, it computes the factorial iteratively. So let's say that I want to actually like figure out which is way faster, right? I want to figure out like whether the iterative approach is faster or the recursive approach would be faster. So what would be the easiest way to figure this out? Anyone? Let's make this more interactive. So what would be the easiest way to figure out like which takes which amount of seconds and the other one takes this amount of seconds? What would be the easiest way to do here?
Add a console log.
Add the console log, right? So in this case, like we can do something like on which line, Omega? Like, would you prefer like over here or over here?
Yeah, before the first console log the time, then after it we can log the time. So even time difference we can calculate it.
Perfect. So let's actually do that, right? So let me just actually.
Yeah, I mean easiest way.
Yeah. All right. So usually like we would do something like this, right? Performance dot now and start and maybe at the end of this minus start, right? This should basically give us like the number of milliseconds this one took, and let me just change this to let so that we can reinitialize on the second line, and basically copy and paste the third line, right? So this would be basically like what we would do usual in the context of usual ways, right? So what's bad about this? Or like, is there any improvements that we could do maybe like on top of this? Anyone who want to counteract Omega saying like, no, you should not be doing this? No one?
The first thing is we are repeating the code.
Yeah, exactly, right? So that's the first thing, right? So, and the other thing is like, let's say that we actually had like 100 of methods, like in this case, like we'll have to just copy and paste everything, right?
Yeah.
So let's actually see in context of metaprogramming how we can actually tackle this one, right? So let me open up this file, decorators.ts. Let me open up it on a side by side. All right. So here I have a function called benchmark, right? So what I'm going to do is I'm going to add benchmark to these two functions, right? And I'm just going to leave this as it is, right? And I'm going to go here. I'm just going to leave it as of now for the sake of like figuring out like what exactly it does. And let me bring up a terminal. All right. So, okay. So let me just run this one. All right, so as of now, I do see the output from the two console log statements. And, okay. All right. Okay, all right, so basically I do see that on the runtime, I get these two logs, and let's try to actually piece it out. So first, here I have the target, which seems to be like an empty object. And I have the property, which in this case seems to be the name of the function that I'm calling, and also the most important and the interesting one, the descriptor, right? So in this case, this is a type descriptor. I see the value, in this case the actual function, and I have a bunch of other properties that we're not going to talk about today, but like also like, you know, will be sort of interesting down the line if you're like really into metaprogramming. So let's try to focus on this one first. So this is the original function. So what I can do, right, now that I have access to it, can get this one, maybe extract that value, and let's do this, right? Let's try to override this with a function. And maybe just log the args, right? Okay, and of course I have to return something. Let's just return now from 112. All right, and if I get the terminal and basically run this, I should see an error, but I should at least like see the first one. Okay, so in this case it says 37, right? So in this case, it looks like we have sort of overridden that function by introducing this decorator, so to speak, at the top, right? So with that knowledge, let's try to actually do what we did, like time the function over here. So let me do this instead, right? So let me try to get the actual value that I need to return. So let me just call it result. Just going to call it an unknown for the moment, right? Okay. So this is going to look a bit cryptic as of for the first time. This, and let's just call args. So all it does, it's like in simple terms, it just does this. In this case, like avoiding all the types, and by any chance, like if the original itself becomes undefined by any chance during the runtime. So just a bunch of sanity checks and like avoiding type checks. So I'm just going to get the result, and I'm going to return the result. Right. So if I run this now, I should see the earlier input, even though it's completely a new like a wrapped function, as like we'd like to call it. All right, indeed, it seems to be working. So what we can do here is then we can implement the starting benchmark, and also let's see ending benchmark. Let's fill in the implementation a bit later, and let's actually run and see what happens. All right, bit weird than what we expected, right? Can anyone tell me like why this happened? I was expecting like just one console log, but ultimately I basically got a whole bunch of lines. So let me open up the code. Can anyone tell me like what could be the reason why it happened?
Because of the recursive function.
Exactly, right? We have a recursive call. So in this case, we would need ideally a way to identify the first and the last. And if you actually write some logic, like you can actually sort of like patch this in a way that you can avoid this. But for the moment, let's just say starting with args, and finishing up with args, and let's do the performance real quickly. Start 20 seconds. All right. So if you actually do this, we should be able to see the top and the boast on, and also like notice like this only happens on the recursive one. Like if you actually comment out the factorial, iterate recursive, and like just leave the iterative, should ideally see only 2 lines. And indeed, like we see that it took about 1.75 milliseconds. So let's actually uncomment that and see this in action. All right, so you just need to take in the last one. In this case, it says we do see the recursive call stack. In this case, all the arguments that were like passed in on each recursive call. And finally, we see that in this case, it took 5 milliseconds for the iterative one. So we can actually indeed like log the name as well. Just do this. The property and all right. So indeed, the recursive one took about 10 milliseconds in this case, and this one just 2 milliseconds. All right. So that's basically how we can use it for analysis, right? So if you compare like the first and early approaches, you can imagine like now here, had I like actually had the same logic over here, I would have had to like edit multiple lines. But in this case, like I just keep my analysis logic clean apart from the code. And like you can, if you actually like move on to the next example, we can actually see like how this can be very beneficial. Like if you are, when it comes to components like unit testing, for example. So before I move on to the next one, which is memoization, any questions? It doesn't necessarily have to be like a question. It can be like in context of like, you know, a comment and as to like why this not be beneficial, or why can this be, where can this be beneficial. Or all questions are welcome. There are no stupid questions, as they say. Okay, all right, let's move on to the next one. Okay, so just gonna remove this, right? Let's actually do memoization. So let's say that I want to basically, every time I compute the value, I want to keep it in like basically cache the value and reuse it whenever possible instead of like running through the whole computation, right? Again, a mundane approach would be like, you know, implementing the logic over here or like outside the function. Like let's say, for example, you define like a private property over here saying cache, which can be form of a object, right, where it takes keys and a value. So in this case, it would be like a number, right? So this would be like the way to do that, right? Like if you were to like follow the traditional approach, and you'd basically like on this line maybe just populate the cache, get the result over here. There are multiple ways. I'm like just eyeballing the most easiest and the most obvious way to do this, and basically n equals result, argument is a number, so let me just make the number. This has to be this dot cache. All right, so something like this, and then at the top you would have something like if this dot cache has a one property n return cache dot result, right? Something like this. Sorry, cache dot n. All right, so and you basically copy and paste the same logic onto the second function. So let's see actually how we can do about this using more of like a metaprogramming approach. So let me just revert all of that, take this one off. Right, let's open up this one, memorize. So what I'm going to do, I'm going to do the exact same thing, right? First of all, I'm going to get a reference to the original function, which we can get from value, right? And also I'm just going to have my cache over here. So let's say string, and let me just call this unknown, right? And let's try to do this real quickly. Descriptor.value, which is also again going to be a function. Taking a bunch of args and done something that's unknown. Right. Okay. So let's real quickly do this, right? So let me compute the key and let me just do it in the most hackiest and the ugliest way. Let me just join them and create the hash, right? So this would be the key. Ideally, you should be using something like hashing or some sort, than just joining it and like using that as the key. But just for the sake of demonstration, I'm just going to use it. All right, and if cache dot has one property key, we're just going to return the cache key. If not, what we have to do is we need to get the result. So let me just real quickly call that function original, and also like you can technically pass null over here, but if by any chance if there are like entities that refers to the instance itself, like that will break. So that's the reason why we have to pass in like if, sorry, this, and let me call in the args. All right. And let me populate the cache equals result, and return the cache key. But okay, actually, okay, just remove this one. All right, looks better. All right, so let me just add a console log statement over here. Using value from cache frog. All right, looks all good. All right, so what is left? Let's actually make it more interesting. Let's actually add the benchmark, and as well as like let's set the memorization. Right. Let's do this. So let me just add a few more calls over here. All right. Okay, looks all good. Hopefully, fingers crossed, it'll run on what? Let's check the odds of like running on the first go. Okay, not bad. All right. So you can see in this case, finishing up. Let's try to scout the log. Did we actually get it from the cache? Okay, all right. Reusing value from cache for arg37. And of course, we also have here, in this case, reusing value from cache for arg37, in which case it took less than 1 millisecond, 0.09, whereas the first iteration it took about 1.8 milliseconds. And if you actually scroll down, iterative approach took initially 4 milliseconds, whereas from the cache, basically, it should be constant time, and technically it's almost near constant time. All right. What questions do we have on that? Either I explained it really good, or I explained it in a very shitty way that there are no questions. Which one is it? Okay. All right. Okay. So in that case, like, let's move on to the next one. Okay. So let me open up transformers.ts. Right. So this is more of like a use case that I actually come across on daily life. Right. So in this case, I have a mock API, mock class. It just returns a data object. Right. So if I were to just log this, it's not. Right now it's very uninteresting, it just logs this object. All right, so as we JavaScript folks like to work with camel case, right? Then this is in basically snake case, right? So not the idea for us. So let's say that you have a API that you need to integrate with, and that API by default sends all responses in basically this particular format. So you can imagine like there could be multiple methods within this class that basically calls different resources of that API and gets the data. If you were to take again the traditional approach, you would basically implement a method that would iterate over this object and then convert it onto camel case, and then you would basically call it over here. We can use the same approach when it comes to metaprogramming. That the advantage is that this won't be captured in the unit test, right? So in this case, like, you would basically test the actual function where like you actually do exact logic within the function. So instead of like that, you don't have necessarily like, you can test the decorator where you convert all the underlying non-business logic separately and keep your business logic clean in this case. So let's actually have a look at like how we can do about that, right? It's pretty much the same, right? So let me just quickly copy this and also copy this so that I don't have to retype. So let me just delete all of this, right? So what I can do is, in this case, let's get the result by calling the initial API. This arcs, all right, and let's try to map this just for the sake of like doing this very quickly. I'm just going to use Lodash, and I'm not going to implement the whole iterative where you're going to iterate through the whole object and like convert all the keys. So I'm just going to like use the dirty way. Let's quickly import Lodash, and let's just, in this case, since it's just object, right? Let me just use map keys. Okay, the result, and I think if I remember properly, it has to be the value first, and the key, which is going to be type of string, obviously, and let's actually use Lodash camel case itself to convert this, and let's do key. All right. Why is this? Okay, yeah. Fix that real quickly. All right. Okay, looks good. All right, fingers crossed. Okay. We have the result. We have the key. Camel case key. What could be going on here? Anyone? You want to basically debug this case? Okay, I know the issue. All right. Can anyone tell me what could be the issue? It should be this actually. It's a very simple issue. Why is it not converting onto camel case as it's supposed to? Any idea? Okay, no one? I didn't apply the decorator, so I need to apply the decorator, and basically it's not from Lodash, it should be from decorators. And if I run this, and indeed we have the object camel cased, object keys camel cased. So ideally this implementation, you should like check if it's an array or like do all that logic over here, and then you can imagine like if you actually have like different methods that calls different resources of an API, like you can basically do all of that. And not just that, like you can do any sort of transformations where you check for errors and then throw, instead of like within every method checking if this response has a error property and then like throwing it everywhere. Instead of doing that, you can just basically add something like filter except filter errors or something like that, and then just implement that logic on a common place, and then apply the decorator onto all the functions that basically need to work with. All right. What questions do we have on that?
Ashen, is it only for like class components, or can we do it on the functional components like arrow?
At least for JavaScript, like you can't, even with TypeScript. As of now, you can't, because JavaScript natively don't support decorators just on pure functions. But if you take like a programming language like Python, of course, you can do that right on the function itself. Good question. And in fact, like if I actually open up, as of now, we've been doing only like on methods, but also like do realize like we can actually do this on like the class level itself. So we can actually apply a decorator on the class method itself that can basically modify properties, methods, and everything within the class itself, or even basically return a new subclass, so to speak. Like, so if you are familiar with things like meta classes, so you can actually sort of mimic the same approach over here. All right, good question. What other questions do we have? Next up is a challenge. So if you all have any questions, feel free to throw all of them right now itself. Otherwise, we can move on to the challenge itself straight away. Okay. All right. So the challenge is a pretty simple one, right? So as of now, there's a. If you actually go to the repo, it should be available under the subfolder challenge. If you go to index.ts, we have a class that says basically challenge, and all it does is it has two methods, get posts and get comments, and it uses this mock API, right? So basically how it works is this. So let me just real quickly bring a browser. All right, so this particular mock API, right? So by default, it has 100 posts, and it supports pagination by query parameters _limit and _page. So for example, if I go to the 99th page with a limit of 10, should see okay, because technically it only has 100 posts. So in this case, I should be able to see anything on 9. And basically, if I go to something like 11, I should be seeing an empty array. So the idea is, as of now, it only fetches the first 10 posts, and also it has a route called /comments, which basically has 500 comments. So the goal here is to basically paginate and basically fetch all the comments and as well as all the posts. If you by any chance have used this API, you do realize that if you just actually call /post, you get all the posts. But okay, for the sake of this challenge, we can't use that. We have to use the pagination query parameters. All right. So basically, let me real quickly run this. So let me just copy this, comment these two out. These are a bunch of tests. So if you actually run this, you should be thrown a bunch of assertion failures. So it should basically say that it expects 100 and 500 comments. So let me just comment that out and copy this. you actually just give this, let's say limit 10 and page 10, you should get an empty array. So that's the only way to figure out like whether we have actually come to the end of the data itself. Okay. Yeah, it should be 11. Okay, I didn't see an empty array. Yeah, indeed. So that's the way to figure out like whether we have reached the end of the pagination. With that in mind, the challenge is to basically complete the decorators. So there's a decorator called paginate. Ideally, if I apply paginate onto these two, instead of getting just the first 10 posts, I should get all the 100. And also like when it comes to this one, instead of just getting the first 10, I should get all the 500. So basically, you need to get the first response and keep iterating till you basically come across an empty array. And that logic ideally should go in the decorator. So ideally, I think we should be able to pull this off within like 20 minutes of time. So whoever finishes first and basically submits the commit. So commit as in, so once you just go to GitHub, right, just clone the repo. Make a clone of the repo, push, and basically give the commit char, right? So if you just click on the commit char, you get the commit URL, and whoever posts that commit URL on the first correct submission on the WhatsApp group will basically get the voucher. Let's start. Good luck.